Yeah. Yeah.
Number 100, 10.1.
100. I like this. Oh, okay, beautiful. Okay, so this is a one little thing we got to review that I know everybody really liked last time. Oh my gosh. Whatever. All right. What's it say again? I'm sorry. You got it right there? 6th root of.
And 4 minus 3t.
Okay. So what part of this tells you you have work to do? There's one piece that if I change that number, I would really have no work to do. I can just put the answer down. Can anybody tell me what that is? The 6. Right? It's a 6th root. It's an even root, which means there's a restriction. Right? If it was a 11th root or some odd root, they don't have any problems anywhere. There's no restriction because of that root. 6th roots can only handle what kind of numbers? Positive or 0. Oh, you're like,
Yeah.
what else is there, man? It's not negative. Yeah, all right. So non-negative, which means not positive, it means 0 and positive. So the inside, what's got to be true about this inside? Because of this being an even root, this has to be greater than or equal to 0. Solve for t, you're done. You write in, you say it in English and then you write it in mathish, what the restriction is. Solve it and you see all the values of t that make sure this will happen. That's what you do when you solve that. Yes?
What do you do for 105 when there's like nothing on the outside?
What do we understand it to be if there's nothing there? What's it known to be? If I just have this symbol.
2.
Yeah, it's a 2 there, understood 2. It's a square root. Why don't we put the number there? Because it's the most commonly used one. We just said we're just going to not put a number there. It's sort of like when I write this. There's no 1, there's no 1, there's no 1. Oh my God, it's surrounded by all these. We're not going to write that all shit all the time. We just know it. So here we just know it's a 2.
Okay.
I like it. Anything else from homework? So how would this have been different if the question would have been this?
All this?
By the way, this isn't done. You guys know if you haven't worked. Yeah, this would have been all real numbers. Why? Odd roots can handle negative inputs. Because when I raise a negative number to an odd power, the answer is still negative. But the minute I raise a negative number to an even power, all the negatives cancel. It's always positive. That's why these guys cannot handle negative inputs. It becomes something else that we haven't even learned yet. Did you have a...
Yeah. When you divide by negative, does it also apply when you switch the sign?
Totally.
Okay.
Yeah, it's independent of where this came from. When you're solving this, you've got those rules that you live by. It doesn't matter that it came from that thing. It doesn't matter. Okay. Okay. Anything else from homework stuff at all? I'll be reviewed now. Okay. So the next, oh yeah, the next kind of big thing we did was we made a connection between radicals and fractional powers. So now we know, for example, how would you rewrite cube root of y? What's another way to write that? Y to the 1/3. All right, so we talked about it, we did examples of why that makes sense, but fundamentally, the cube root breaks something into 3 parts multiplicatively. So it's 1/3 of it multiplicatively. So if I put the number 1/3 in the spot that's controlled by multiplication, it makes sense. That means the same stupid thing. So we looked at, for example, we looked at this. What is the cube root of 27? 3, because it takes 3 3s to multiply to be 27. This does not mean divide by 3. We already have symbols for that. Why wouldn't we make a radical symbol for that? So I'll put 9 there. If I look at it this way, these are supposed to be equal to each other, right? Become a 3. What is 27? 3 to the...
Third.
And what do I do with powers in this case? Yeah, because I multiply them. So do I get the same answer either way? Shit, yeah. There you go. So it's not a complete proof, but I mean, it's true. Okay. So just to go that next step with this, how would I rewrite this? What do you got, Jeff? Oh, yeah.
X
Remembers the shortcut.
over 7.
Yeah. Because what goes on the bottom?
The
The root. Because roots are on the bottom. Right?
So 7.
And what goes on the top?
4.
It's freaking powerful. It's the power. Oh, it's the top. Okay, I like it. I like it. And if I had my way, these symbols wouldn't even exist. But I didn't. I wasn't around. Thank God, I'd be really old now. I was there when they did this. Hundreds of years ago. Alright, sorry. So, we got to finish up that sheet, so let's see. For the benefit of some of you guys, just let's do an example like some of the stuff we did last time. What would I have to do with this? What do you got, Jeff? It doesn't. Just put a number. There you go, buddy. What do you have to do with this?
Get the denominators, you said?
Why?
So you can add them.
Good, because the property doesn't give a shit what's up there. In fact, I've done a problem. I gave you a problem sort of like this before. Right? I at least did a bonus question. I know I talked about it. This really freaks people out, but no. What's the property say? Are the bases the same? Yes, and I'm multiplying them. So what do I do with the powers? Add them. So what do you get? X to the
I'm sorry. Never mind.
3.
n plus 2m is 3m. 1 minus 4.
3.
That's it, right? The rule, when the bases are the same and you multiply, you add the powers, does not say anything about what the powers have to be. It does, because it doesn't matter. Whatever they are, you add them. So when I have powers that have letters, have variables in them also, I need like terms. When I have powers that are fractions, I need like denominators. Those things don't change. So yeah, you're right. What is this guy's getting? 9. This guy's getting 5. I get 18 plus 20. W to the 38 over 45. Is that cool? Okay. I like it. And of course, if I would have divided by W to a power, I have to subtract the powers. I still need LCD.
Would you ever want to reduce the...
Yeah, can you reduce that? No, but yeah, you still, a fraction, I don't care where a fraction is, anywhere in the universe, if it's reducible, you reduce it at the end. Yeah, I like it. That one won't go anywhere. I like it. Okay, so let's finish this one off. I think we actually, I think we finished 1H, right? We got through with 1H?
Yeah.
So then we had 2A's. Everybody got that sheet I'm referencing right now?